Welcome to my channels. In this video, we are going to implement a Chebyshev step-impedance low-pass filters. And the filter satisfies the following criteria. The order of the filter is 5. The passband ripple is 0.5 dB. The high-end impedance is 120 ohm. The low-end impedance is 20 ohm. The reference impedance is 50 ohm. Okay, so we are going to implement this filter. So to begin with, we need to know that in step impedance filter, we use high zip to implement a inductor. We use low zip for implementing a capacitor. So in an inductor, we are going to use a thin transmission line. The characteristic impedance of this transmission line is, say, 120 ohm. Yeah, it is a user-defined value. The length here is beta L, and because V and sorry, beta L is equals to J omega L, and we know that beta L is going to be equals to omega L divided by V naught H. And as a rule of thumb, this can be approximated as we can do that. And for capacitor, we can use a very wide transmission line to implement this. And say the low Z is equals to 20 ohm, and the length here is low J beta L, and then beta L is equal to, and as a result, we have V naught and divided by V. And normally we express the length, the electrical wavelength in degree. So in this case, the answer that we can get here is radian. We need to convert it into degree. And similarly, we are going to do the same for the capacitance. Okay? So now the next step is to actually design the filter. The first thing that we need is to determine the filter coefficients with the provided information, which includes the order of the filters, the passband ripples. The order of the filter is 5. The passband ripple is 0.5 dB, and with this I've got G1 equals to 1.7058, G2 I got 1.2296, and I got G3 equals to 2.540, and G4 is 1.2296 again, and this is just a mirror copy of G1, which is 1.7058. So this is the filter coefficients. And in terms of the lump elements value, we know that C1 is equals to 1.7058, L2 is equals to 1.2296, and C3 is equals to 2.5408, and L4 is equals to 1.2296, and C5 is going to be 1.7058. So this is now we are in a position to calculate the electrical wavelength beta L. The way how we calculate it is to use the formula. The formula for capacitance and the formula for inductance are different. So let's try it. The first one is the capacitance, and the formula is L and divided by C naught. And in this case, it's going to be 1.7058 times 20 and divided by 50. And obviously, we need to change it to degree. So, according to my calculation, is 39 degree. And this one is an inductance, so we need to use the formula here, L 2 Z naught, and then divided by V high. And with this in mind, I got 1.2296 times 50 and divided by 120. So I got this, and with this in mind, I got 29.36. And similarly, we can do the same step for C3, C4. We do it for C3, right? I will do it, and then and then 2.5408 times 20 times divided by 50. So again, we are going to convert it into degree. And if you do it carefully, you got 58.23 degree. And similarly, we are going to do the same for L4. So L4, and the formula will be the same. And this one is going to be the same, right? It's a mirror copy of L2. $29.36. And similarly, G5 or C5 is going to be the mirror copy of G1. And I'm going to just copy and then 39 degree. And you don't need to, you can use other high impedance value, other value for the high impedance, or say 150 ohm. And for the low seed, you can use 10 ohm. Yeah. So now, based on the information here, and you would agree that the middle section CV is going to be electrically or physically longest, and the section for L2 and L4 is shortest. So I'm going to sketch the filter filter structures to you. So we have 39 ohms, 20 ohms for all the capacitance. So I will do that. So it's quite large, and you have 120 ohm for the inductance, and the middle capacitance is longest. So I will make it more exaggerated. The width should be the same as the first one. The width of the first one should be the same as the first one. So this one, will be like this, yeah. And this one, here I will just say the twenty ohm, the low C is 20 ohm. The electrical degree here is 39 degree, and This one, again, the same. The electrical degree is 58. And here, according to here, the characteristic impedance for no seed is 20 ohm. And E here is 39 degree. And the inductor, the characteristic impedance for the inductance is 120 ohm. The electrical wavelength is 29.36. Okay, and this is this value, and this one the same. And E is equal to 29.36. And finally, the in-output port should be based on the reference impedance. The reference impedance is 50 ohm. And similarly, here will be the same. And this is Z. Okay, so this is the value you can get from ADS or other software like Code Studio. If you have any questions regarding this question, feel free to ask me in my office, or you could eagerly leave your questions to the comment sections of this video. Thank you.